mga kaagsikaping, panibagong araw, panibagong kaalaman na naman mga kaigan. Inspired by. So, for today's video, we are going to discuss two topics related in our subject, Highway and Railroad Engineering. Yes, because this is a group vlog. So let me introduce to you our two gorgeous ladies with confident and beautiful heart. So this is,
hello everyone,
and this is,
hi there, I'm
and
Robielyn.
I am Cedrick. So kaming tatlo makakasama ninyo sa araw na ito. I hope marami kayong matutunan. Let's get started! So, for the first topic guys na i-discuss namin sa inyo is about scheme appraisal for highway projects. Once the transportation plan has been finalized and yung mga demand highway links ay na-establish, kailangan yung process ay mailagay sa tamang lugar. Kasi makakatulong yun to have a best solution sa bawat individual proposal. At yung project na yun, sila yung nag-subject sa or to an appraisal. Yung highway appraisal process ay napakahalaga. Sana all mahalaga.
Sino man para sa akin, di ko
So, napakahalaga ng highway appraisal process kasi it determines the economic, societal, and environmental feasibility ng isang project. Isa pa, yung process na yun ay nakatutulong sa mga highway planners natin to decide whether a project is desirable in absolute term and also provide a means of choosing between competing project options. So, una na dito yung tinatawag nating economic appraisal of highway schemes. So, yung economic appraisal, it can be used to justify a scheme in absolute term, in which case the decision is made on the basis of whether the project is economically efficient or not. Kapag yung negative net present value at yung benefit-cost ratio ay less than sa unity, nag-indicate sa inefficient scheme na maaaring mag-end up worst yung ating society kapag wala yun. So, this appraisal is being used to help differentiate between economic performance of competing options under examinations. The scheme with the highest measure of worth will be deemed the most efficient, assuming that at least one will have a positive net present value or a benefit-cost ratio is greater than unity. So, this framework within this evaluation referred dun sa tinatawag nating cost-benefit analysis. So, yung pag tinawag nating cost-benefit analysis, ito yung nag-utilize ng present net value kung saan yung cost and benefit ay discounted over time so that they can represent present day's values. So, may mga steps dito na sinusunod at una na dito yung identify the main project option. So, this is a fundamental step in CBA process o yung tinatawag nating cost-benefit analysis nga. Where yung decision makers, ina-compile niya lahat ng list ng all relevant feasible options na gusto nilang i-assess. So, yung term na feasible ba yun ba yung na-feasible yung bola? Wala yun. Okay. So, yung term na feasible refers to an option on preliminary evaluation. Present themselves, available to option on preliminary evaluation. Present themselves, available courses of action that can be brought to completion given the constraint imposed on the decision maker such as lack of time, information, and resources. So, maraming procedure in identifying projects. Yung una na dito is yung drawing on the personal experience of the decision maker himself as well as other experts in the highway engineering field. Pangalawa is making comparison between the current decision problem and one previously solved in a successfully manner. Pangatlo is examining all relevant literature. May gumagamit ng brainstorming session na quite effective in bringing viable options to life. So, yung brainstorming session na yun ay may two main phases. So, yung unang phase is yung non-critical phase. Ibig sabihin, sa phase na yun, yung member ay should avoid being critical of their own ideas or those of others, no matter how far-fetched it is. Then, yung second is yung required naman sa mga planning engineer na to return into judgmental. So, kung yung una is parang bawal kang maging judgmental sa idea mo. So, second phase, kailangan mo maging judgmental. Pero yung normal lang. Kasi, yun ay para maka-select ng best option, analyzing each technologically, environmentally, and economically. So, in this phase, yung iba gumagamit ng T-chart kung saan sa T-chart na yun andun yung list ng criteria which is kung alin dun yung acceptable or not. Tapos yung next step is yung identifying all relevant costs and benefits. So many of the benefits of improvement to transport projects equate to decrease in cost. The primary grouping that contains this type of economic gain is termed user benefits. Kasama sa groupings na ito yung reduction in vehicle operating cost, savings in time, reduction in the frequency of accident. Sa reduction in vehicle operating cost, it is one of the most important and easiest to measure in terms of money. For highway schemes, the new upgraded projects lead to lower levels of congestion and higher speed than existing roadways, usually resulting in lower fuel consumption and lower maintenance costs. Totoo naman kasi kapag halimbawa yung sa mga highway, kung maayos yung daanan, hindi siya masyadong inconvenient para sa mga sasakyan. Hindi man yung fuel din kasi depende. Yung kain ng fuel ay depende sa paano gumalaw yung isang sasakyan. Halimbawa, kung bako-bako, syempre, mas malakas yung kain ng fuel. Tapos, pag mga bako-bako, magiging mas magastos pa para sa mga repairment ng sasakyan, diba? Unlike kapag maayos yung daan, less ang kanilang maintenance. Next is yung saving in time. The upgrading of highway installation will reduce travel time as well as improving the reliability of transport services. Kasi kapag maayos yung sasakyan, mas maayos yung yung pag-travel and hindi siya ganun ka-inconvenient. Last is yung reduction in frequency of accident. Kasi normally yung kapag constructed on higher standard yung ating mga highway na yung rate ng accidents ay nababa. So next is economic life residual value and the discount rate. A highway project is often complex and long-term with the cost and benefit associated when occurring over a long time frame, which we term the life of the project. The project may well have to be assigned a substantial residual value reflecting the significant benefits still to be accrued from the projects or conversely costs still liable to be incurred by it. In addition to this, the cost of benefits occur at different times over this time horizon. They cannot directly combine until they are reduced to a common time frame. This is achieved using another parameter introduced earlier, the discount range, which translates all costs and benefits to time equivalent values. Next is yung use of economic indicators to assess basic economic viability. Once two parameters of project life and discount rate are set up in place, this allows all costs and benefits to be directly compared at the same point in time. The decision maker must now choose the actual mechanism for comparing and analyzing the costs and benefits. So dito, pwede natin gamitin yung three techniques. Yung net present value, yung NPV, yung internal rate of return and benefit cost ratio, yun yung mga yung related sa kanina. All these three methods depend on discounting to arrive at a final answer. If it is used correctly, it gives the answer consistent with each other. So, may mga disadvantages at advantages ang cost-benefit analysis. So, una na dito, sa advantage niya is the use of the common unit of measurement, money, facilitates comparison between alternative highway proposals and hence aids the decision-making process. And isa sa disadvantage is yung constructing highway project may be societal or environmental rather than economic one. If the decision is based solely on economic factors, however, an incorrect decision may result from the confusion. So, sa next topics, si Robielyn naman ang mag-discuss. So, Robielyn.
Payback analysis. Payback analysis is an extremely simple procedure that is particularly useful in evaluating proposals such as privately funded highway projects where tolls will be imposed on users of the facility in order to recover construction costs. Naghahatid ang pamamaraan ng isang pagtatansya ng haba ng oras na kinuha para sa proyektong upang makabawi sa mga gastos ng construction ito. Hindi ito nangangailangan ng impormasyon sa isang naangkop na interest rate, ngunit ang kawalan ng kawastuhan ng pamamaraan ay nangangailangan na ang mga resulta mula dito ay hindi dapat bigyan ng parehong bigat ng tulad ng mula sa formal na diskarte o tulad ng cost-benefit analysis. Ipinapalagay ng pamamaraan na ang isang naibigay na proposal ay bubuo ng isang stream of monies during its economic life. At sa ilang mga punto, ang kabuuang halaga ng stream na ito ay eksaktong katumbas ng paunang gastos. Ang oras na ginugol upang maganap ang equalization ay tinatawag na payback period. Mas kapaki-pakinabang itong inilalapat sa mga proyekto kung saan ang timescale para sa pagpapantay ay medyo maikli. Ang pamamaraan mismo ay hindi tumutugon sa pagganap ng panukala pagkatapos ng panahon ng pagbabayad. While the method has certain shortcomings, it is utilized frequently by engineering economists. So, payback period is computed by payback period represented as N sub P is equal to the initial construction cost of the highway project divided by the net annual savings. Environmental appraisal of highway schemes. While the cost-benefit framework for a highway project addresses the twin objectives of transport efficiency and safety, it makes no attempt to value its effect on the environment. Sa makatuwid, ang pagsusuri sa kapaligiran ay nangangailangan ng isang alternative analytical structure. Ang strukturang binuo sa loob ng huling 30 years ay tinatawag na Environmental Impact Assessment or EIA. So the procedure has its origin in the US during the 1960s when environmental issues gained in importance. Ang legal na pangangailangan para sa konsultasyong pampubliko habang nasa yugto ng pagpaplano ng isang highway project ay kaalyado sa mga issue sa kapaligiran ng environmental group. Ito ay nagresulta ng pangangailangan para sa environmental assessment within the project planning process. So the process was made under the National Environmental Policy Act 1969, which requires the preparation of an environmental impact statement for any environmentally significant project undertaken by the federal government. So, ang NEPA ay nag-require ng mga assessment para sa development. So, the probable environmental impact of the proposal, yun ang unang-una. Second is any avoidable environmental impacts. Next is alternative option to the proposal, short-run and long-run effects of the proposal and any relationship between the two. And lastly is any irreversible commitment of resources by the proposal. So, yung mga nabanggit ko na yon ay mga tumutulong sa pagkilala at pagsusuri ng lahat ng mga epekto na nauugnay sa pagsusuri ng concerned projects. So, the 12 environmental impacts forming the assessment frameworks are air quality, cultural heritage, construction disturbance, ecology or nature conservation. Ito yung mga effects sa certain wildlife species, landscape effects, land use, traffic noise and vibration, pedestrian, cyclist and community effects, vehicle travelers, water quality and drainage, geology and soils, and lastly is the policies and plans. So the new approach to appraisal or NATA. Dito sa NATA, noong late 1990s, the UK government reviewed its road program in England and identified those strategically important schemes capable of being started within the short to medium term and listed them as potential candidates for inclusion within the targeted program. So this appraisal summary table or AST is designed for presentation to those decision makers charged with determining whether approval for construction should be granted, and if so, what level of priority should be assigned to it. So the AST summarizes the assessment of the scheme in question against the following 5 objectives. So una na dito ang environmental impact. Under environmental impact ay noise, air impacts, landscape, biodiversity, and heritage and water. Next is safety. Followed by economy, and under economy is journey times, cost, journey time reliability, and regeneration. At sumunod dito ang accessibility. Under accessibility is pedestrians, access to public transport, community severance, and lastly is the integration. So the final assessment is given using the standard AST 7-point scale. Una na dito ang beneficial. Next is adverse. Sa adverse, ito yung journey times increase at sa beneficial naman ay yung journey times reduce. Slight, fewer than 200 travelers are affected. So dito din sa slight, journey times are changed by less than 1 minute and there is no change in amenity. Next is large. Typically, more than 1,000 travelers are affected. So dito sa large, ang journey times are changed more than a minute and there are changes in amenity. So the assessment in all intermediate cases will be moderate. The basic elements of highway traffic analysis. So the function of effectiveness of a highway is measured in terms of its ability to assist and accommodate the flow of vehicles with both safety and efficiency. In order to measure its level of effectiveness, certain parameters associated with the highway must be measured and analyzed. So these properties include the quantity of traffic, the type of vehicle within traffic stream, the distribution of flow over a period of time, na usually is 24 hours. Next is the average speed of the traffic stream, and lastly is the density of the traffic flow. So the analysis of these parameters ay direktang may impluensyahan ang sukat at layout ng iminungkahing highway, kasama ang uri at dami ng mga materyales na ginagamit sa pagtayo nito. So ang prosesong ito ng pagsusuri ay tinatawag na traffic analysis, at ang mga section ay nakikipag-ugnayan sa pagitan ng mga parameter na nakasalalay dito. So, the speed, flow, and density of a traffic. So, ang traffic flow na represented by Q ay nako-compute sa traffic flow is equal to N. N is the number of vehicles over the passing some given point on the highway in a given time interval represented as T. So, Q is equal to N over T. In general terms, traffic flow is expressed in vehicles per unit time. So, the number of vehicles on a given section of highway can also be computed in terms of the density or concentration of traffic flow as follows. K is equal to N over L, where the traffic density K is measure of the number of vehicles N occupying the length of the roadway. So, yun yung L. L is the length of the roadway. Speed density relationship. In a situation wherein a car is traveling along a highway, densities by definition be near to zero, and the speed at which the car can be driven is determined solely by the geometric design and layout of the road. Such a speed is termed free flow speed, as it is in no way hindered by the presence of other vehicles on the highway. Tulad ng maraming mga sasakyan na gumagamit ng highway section, ang density ng daloy ay tataas at ang kanilang bilis ay mababawasan mula sa kanilang maximum na halaga ng free flow. If traffic volumes continue to increase, a point is reached where traffic will be brought to a stop. Thus, speed will equal to zero with the density at its maximum point as cars are jumped bumper to bumper, or termed as jump density, represented by Kj. In mathematical terms, this linear relationship gives rise to the following equation. This assumption of linearity allows a direct mathematical linkage to be formed between the speed, flow, and density of a stream of traffic. This linear relationship between speed and density, put forward by Greenshield's 1934, leads to a set of mathematical relationship between speed, flow, and density. In mathematical terms, this linear relationship gives rise to the following equation. This assumption of linearity allows a direct mathematical linkage to be formed between the speed, flow, and density of a stream of traffic. Flow-density relationship. The following direct relationship between flow and density is derived. This is a parabolic relationship and is illustrated below. In order to establish the density at which maximum flow occurs, the equation Q is equal to U sub F times the quantity of K minus K squared over K sub J. So that would be all, and now let's welcome my groupmate, Chrishna.
So guys, ngayon i-discuss ko naman sa inyo yung determining the capacity of the highway. So meron tayong two different approaches to determining the capacity of highway. Meron tayong the level of service approach at meron din tayong QT approach. So ngayon, natin i-discuss yung level of service approach. Ano ba ang level of service approach. So it involves establishing, from the perspective of the road user, the quality of service delivered by a highway at a given rate of vehicular flow per lane of traffic. So ito'y kadalasan ginagamit sa bansa katulad ng bansang US. So para mas maintindihan natin kung ano yung level of service, it also describes in a qualitative way the operational conditions for traffic from the viewpoint of the road user. So ginagamit dito yung variable na travel time and traffic speed para malaman yung level of congestion sa isang highway. So in order to determine a road level of service, a comprehension of relationship between hourly volume, peak hour factor, and service flow is vital. So i-discuss natin kung ano nga ba yung mga hourly volume, peak hour factor, and service flow na yan. So hourly volume is the highest hourly volume within a 24-hour period. Peak hour factor naman is yung ratio of the hourly volume to the peak 15-minute flow enlarged to an hourly value. So meron tayong formula ng peak hour factor na hourly volume over dun sa hourly volume to the peak 15-minute flow times 4. Service flow naman is yung the peak 15-minute flow enlarged to an hourly value. So meron din tayong formula para sa service flow. Ito yung service flow is equals to the hourly volume to the peak 15-minute flow times 4. So ngayon, tumunga tayo sa maximum service flow rates for multi-lane highways. So the highway capacity manual generates maximum flow values obtainable on a multi-lane highway given a certain speed limit and prevailing level of service. The values assume that ideal conditions exist. So ano nga naman ibig sabihin ng ideal conditions exist? So ang ideal condition exists ay ito yung tumutukoy sa all carriageways are at standard width na 3.65 meter. Tapos, wala siyang obstruction within dun sa 3.65 meter na yon. And also, wala din yung mga heavy good vehicles such as trucks, buses, at yung mga recreational vehicles. So, given the existence of ideal conditions, the maximum service flow or service flow max can be defined as service flow max is equal to Cj times V over C times N. Kung saan yung N is the number of lanes in each direction, Cj is the capacity of a standard highway lane for given design speed J. So next is meron tayong mga tables dito, which is dito makukuha yung mga value ng mga variables na nandun sa formula natin. So, table 4.1 is the values of Cj for different design speed. So, the maximum ratios of flow to capacity for each level of service and design speed limit are given naman sa table 2.2. So, nakadepende dun sa mga design limit kung ilan yung capacity ng passengers per hour per lane at nakadepende din yung mga values niya kung ano yung level of service. Ang formula natin na yun is para sa non-ideal conditions lang. Paano naman doon sa mga non-ideal conditions? So, yung mga non-ideal conditions ay yung mga kasalungat ng ideal conditions na sinabi ko kanina. Yung may mga heavy good vehicles, na trucks, merong recreational vehicles, merong bus, tapos merong obstruction. So, for the non-ideal conditions, the formula for service flow max becomes the following. So, ito na diba yung ating service flow max sa ideal conditions. So, magiging ganito siya. Service flow is equal to Cj times V over C times N times FW times HV times FP and FA. So, when lane widths are narrower than 3.65 meter and or barriers, lighting posts or any such obstructions are closer than 1.83 meter from the edge of the traveled pavement. So, yung ating FW is yung ating adjustment factor. So, ito magamit din yan sa pag-solve ng non-ideal conditions ng sa multi-lane, pag-determine ng capacity sa multi-lane. So, yung table 4.3 ay correction factors for non-ideal lane widths and clearances from obstructions. So, the passenger car equivalent to P or PCE, or the number of equivalent private cars that would occupy the same quantity of road space for each of the above types of heavy vehicle, is primarily dependent on the terrain of the highway under examination, with steep gradients magnifying the performance constraints of the heavy vehicles. The PCE for trucks, buses, and recreational vehicles. So, ito naman yung table. Hindi natin makukuha yung ating mga value para sa depende kung anong type siya ng terrain. And may kanya-kanya correction factor tayo para sa trucks, bus, and recreational vehicles. So, yung table 4.4 is passenger car equivalent for different classes of heavy vehicles. So, having obtained the necessary PC evaluations, the overall correction factor can be estimated once the percentages of the three vehicle types present along the section of road in question has been arrived at. So, yung percentage of trucks natin is PT, percentage of bus is PB, and percentage of recreational vehicles in traffic stream ay PR. So, given these values, the correction factor FHB can be derived as follows. So, ito yung ating formula para sa FHB. Diba? Kasama yung FHB dun sa ating formula sa non-ideal condition ng multi-lane. So, ito yung kanyang formula. PT, PB, and PR ay yung sinabi natin kayo ng mga percentage ng mga vehicles, while yung EP, EB, and ER naman is yung mga corrections nila. Correction factor. So, itong table 4.5 naman is correction factors for driver population. So, ayan, may driver classification tayo. Regular, weekday commuters, at other classification of drivers. So, dito yung FP natin. Dito makuha yung value ng FP dun sa formula natin sa non-ideal. So, table 4.6 naman is correction factors for highway environment. So, sa highway classification, meron tayong rural, urban, or suburban. Then, meron tayong divided and undivided. So, dyan din tayo kukuha ng value pag magsusolve. Next, topic na maximum service flow rates for two-lane highways. So, kanina is multi-lane tayo. So, ngayon sa two-lane highways naman tayo. So, where one lane is available for traffic in each direction, a classification of two-lane highway applies. Kunwari, yung isang driver is gustong mag-overtake dun sa mas mabagal na vehicle kaysa sa kanya, the opposing lane must be utilized. So, this maneuver is therefore subject to geometric constraints, most noticeably passing sight distances but also the terrain of the stretch of road in question. So, the capacity of such highways is expressed as two-directional value rather than the one-directional value used in the previous sections for multi-lane highways. Under ideal conditions, the capacity of a two-lane highway is set at 2,800 passenger car units per hour. If one adjusts this value by ratio of flow to capacity consistent with the desired level of service, the following formula for service flow is obtained. So, ito yung ating formula para sa two-lane highways under ideal conditions. So, ayan. Service flow divided by 2,800 times V over C. So, para masabi natin ideal condition siya, so, ideal conditions assume the following. So, ito dapat yung katangian nung para masabi na under siya ng ideal condition. So, passing is permissible throughout 100% of the section of highway in question. Lane widths are at least 12 feet or 3.65 meter. Clearance on hard shoulders of at least 6 feet. Design speed of at least 60 miles per hour. The traffic stream entirely composed of private cars. And the flow in both directions exactly evenly balanced or 50-50 split. Level terrain and no obstructions to flow caused by vehicle turning movements, traffic signalization, and etc. So, if ideal conditions obtained, the service flow is obtained using the ratios of flow to capacity associated with the required level of service as given in table 4.7. So, may ako mapakita yung table 4.7. And when conditions are non-ideal, the capacity of the highway reduces from 2,800 based on the following equation. So, kanina yung pinakita kong equation or formula is para sa under ng ideal condition. So, ito naman is para naman sa non-ideal condition. So, ito na yung magiging formula natin para sa non-ideal condition. So, ito yung sinabi ko kanina sa 4.7. So, dito makita yung level of service values for two-lane highways under ideal conditions. Ito, ang table na ito ay para sa ideal conditions lamang. So, table 4.8 naman is the correction factor for different directional splits on two-lane highway. So, table 4.9 is the correction factors for non-ideal lane widths and clearances from obstructions under two-lane highway. So, ito naman is, yung table na to is para sa non-ideal lane widths lamang. So, table 4.10 is the passenger car equivalents for different classes of heavy vehicles. So, ito mga table na to is mahalaga kasi dito tayo kukuha ng mga values nga, depende dun sa problem natin at depende dun sa mga given na data. So, table 4.11 naman, ito yung level of service values for two-lane highways for different percentage no passing zones. So, ngayon, dito naman tayo sa sizing a road using the highway capacity manual approach. So, when sizing a new roadway, a desired level of service is chosen by the designer. This value is then used in conjunction with design traffic volume in order to select an appropriate cross-section for the highway. So, ito yung formula natin para dun sa sizing a road. DDHB is equals to K times D times AA dt. So, ano yung DDHB dyan? So, yung DDHB dyan is directional design R volume. K ay yung highest hourly volume at yung D ay yung directional factor. So, ngayon dumako naman tayo sa sizing a road using the highway capacity manual approach. So, when sizing a new roadway, a desired level of service is chosen by the designer. So, this value is then used in conjunction with design traffic volume in order to select an appropriate cross-section for the highway. So, meron tayong formula na DDHV is equals to K times K times AADT. Yung DDHV natin is directional design R volume. K is the highest hourly volume at yung natin ay directional factor. So, sa problem, ito ay sa multi-lane din, sa two-lane, and dito sa sizing and reducing the highway capacity manual approach. So, ito is substitute lang natin ito sa formula kasi given naman, dinahanapin lang natin sa table kung ano yung mga equivalent, then substitute, direct sub naman siya sa formula. So, ito na yung last natin na topic. Ito naman ay under ng the UK approach. So, kanina yung mga sinabi ko is under international level of service approach. Yung multi-lane, two-lane, saka yung sizing a road. So, dito naman sa the UK's approach for rural roads is the estimation of AADT for a rural road in its year of opening. So, selection of the appropriate layout for a rural road requires that the high and low forecast for the opening year is estimated. This is undertaken using the factors supplied in Table 4.13. So, mamaya papakita ko yung table na yun. That are used in conjunction with present-day AADT figures to produce future flows. These are then matched with the appropriate AADT range in Table 4.12 in order to choose the right carriage type. So, traffic was split into the following 5 categories. So, meron tayong cars, light goods vehicles o LGVs, other goods vehicles OGV1, meron tayong OGV2, and buses and coaches or PSV. So, ito yung sinasabi kong table kanina, yung table 4.12. So, ito yung flow ranges for different classes of rural highway. Meron tayong carriageway type, AADT range, at quality of access. So, dito naman sa table 4.13 is yung low and high growth forecast for 5 different categories of road traffic. So, nakalagay ito yung mga year. Ito, 2000 to 2006, 2007 to 2012, and so on. Meron ding yung ating, di ba, 5 categories, may low and high. Makikita natin ito sa table. So, table 4.14 is the percentage of different vehicle classes in UK for 1994. So, ayan. Ayan yung mga value. So, dito naman sa 4.13 is yung low and high growth forecast for 5 different categories of road traffic. So, makikita natin yung ating 5 categories, tsaka yung year, and kung low or high. So, yung 4.14 naman natin is yung percentage of different vehicle classes in UK for 1994. So, dito nagtatapos yung ating discussion about sa determining the capacity of a highway. So summarize natin yung ating mga diniscuss. So, meron tayo dalawang approach. Yung the level of service approach at UK approach. So, under nung the level of service approach is meron tayong na-discuss sa multi-lane, 2-lane, at exercising a road. So, sa multi-lane, meron tayong ideal condition and ideal condition. So, magkaibang formula yon. Ibang formula sa ideal conditions, ibang formula sa non-ideal conditions. Ganun din sa 2-lane, iba rin yung formula nila sa isa't isa. And sa sizing a road. Sa sizing a road, meron tayong formula na isa, yung diniscuss natin kanina. Then, dito naman sa ating green topic, which is under ng UK approach, is ito rin ay yung mga table na pinakita ko is yun din, dun din natin kukunin yung mga values pag magsasolve tayo. So, given naman sa problem yung mga data, so hahanapin lang siya sa table. So, yun lang. Sana may natutunan kayo sa aming report.
So that's all for today. I hope marami kayong natutunan. So don't forget to like, comment, and subscribe our YouTube channel.
So always take care of yourself, guys.
Bye.
Stay at home and keep safe.